A warm welcome to everyone. The afternoon session is going to be taken by Dr. M. Nagaraju sir. Dr. M. Nagaraju was awarded PhD from Lovely Professional University, Punjab in the year 2022. He received his MTech in Computer Science and Engineering from JNTU Hyderabad in 2012 and his MSc in Computer Science from Osmania University, Hyderabad in 2004. He has presented his research work at 15 national and international conferences and published more than 20 articles in various reputed SCI Index and UGC CARE journals. His research interests include artificial intelligence, machine learning, Internet of Things, and deep learning. Over to you, sir.
Good afternoon, everyone. Am I audible?
Yes, sir.
Okay, if I am audible, definitely your faces will look at me. For that one, I am asking this question. Okay, so before starting this session, I want to thank Tilotama ma'am for giving a wonderful session in the morning. Right, almost I think we have given very less time to the resource person ma'am. Why? Because she is having a lot of knowledge. Almost within the given period only, she could able to cover a lot of topics which are related to artificial intelligence. Okay, and during the time of presentation, ma'am have given a table. If you remember, the table includes 2 columns, and almost at the end there is a word called as production systems. Okay, so that production systems will be my topic for this session. Okay, as you people are very new to the artificial intelligence, it will be very difficult to make you jump from the introductory part to directly to the production systems. Why? Because in between there are a lot of other topics which we need to cover. Why? Because learning process itself is a step-by-step process where there will be some other topics in between. But anyhow, there is no problem. I will try to make all the things more simple, and I will make you understand the things very clearly. If you found any difficulty, you can open up and you can ask the doubts anytime. There is no problem. Okay. So in the morning session, Madam itself has told that there are 2 kinds of problems. Means Madam has given in a different terminology, saying that there are 2 different kinds of programming. Okay. So I want to change the terminology for my session. Okay. That's why I am telling that there will be 2 kinds of problems. Okay, one problems which you can solve with basic programming languages, means generally what you do in C language and Python, generally even what you are doing in your regular lab sessions. But there will be some other kind of problems which you cannot solve with just by doing simple kind of programmings. Okay, if you, I will take some simple examples and I will try to make the things clear. Okay, so for example, if you want to perform the addition of 2 numbers, okay, what you are supposed to think of first? Arithmetic operations. You are going to think about arithmetic operations, and you will try to generate an equation saying it as C equal to A plus B. Yes or no? Similar to that one, if you are dealing with Fibonacci series, you are going to generate some other kind of logic. A kind of expression you are going to generate. Based upon that expression, you are going to perform some variable declarations, taking some inputs, performing the operation and getting some result. Right? What I mean to say is that these are all some traditional kind of problems. They are not the real kind of problems. Why? Because artificial intelligence programs, right? Artificial intelligence programs are not just dealing about the just concept of doing addition of two numbers, calculating the factorial of a given number, doing the Fibonacci series like that. There are a lot of other things, right? There are a lot of other things, right? Still, as I am told that there is a very big scope is there already. A lot of research need to be happened at the artificial intelligence area. Okay, today we will try to see, okay, what are these artificial intelligence kinds of problems will look like, and what will be the complexity that exists in the artificial intelligence programs, and how we can generate programs to solve them. Okay, so that is my actual intention of this session. So by saying this statement, right, the title itself is production systems. Right, if you have any different opinion by seeing this title, just you try to remove it from your mind. Right, because production system is, we are not going to write programs in order to, not writing the programs, we are not going for any manufacturing company, and we are not going to develop any robots. Right, because whenever we use that terminology production, generally we say that okay, we are going to build something. Okay, here it is not such kind of things. Here the production system is completely different, which is related to our programming concepts itself. Okay, now the question is, why we need a production system? Of course, anyhow I am going to tell that what is this production system and what this production system generally includes. But I want to start with a word called as why. Why we need production systems? Okay, so for that one I am using a word called as problem. I am saying it as a problem. For example, think that if you get any problem, so how your thinking will be? For example, think that you got some problem, any kind of problem you take, right? You got a problem, then immediately what kind of things comes into your mind? How to solve the cause of the problem? Cause of the problem, okay. Finding the solution. Pardon? Okay, different ways of finding a problem, solving getting an answer for the problem, and any more? Okay, optimizing. Okay, so okay, fine. So this is the things, means whatever the kind of problem we have, generally we will try to analyze the things. Okay, we will try to analyze some of you told that what are the causes of such problem, and they are going to look for the suitable solutions for it. Okay, so actually there are 4 different steps we have, right, in order to understand our problem. Right, because first of all we need to clearly understand what our problem is, right? Then only we could able to try to generate a good solution. Right, according to morning session, as we have told that generating a solution is nothing but giving a stipulated period of time. Means within a shorter period of time we have to generate a solution for the problems. Okay, so for example, think that I have some problem with me. Okay, it is a related problem. I will tell what kind of problem we have, and we are also going to discuss very deep into that problems. Okay, our first primary duty is we need to define the problem first. We need to define the problem. Defining the problem is nothing but trying to identify the specifications of the problem. Right, as some of you people know that causes for that problem. And also we need to understand what is our initial stage, where we are. What is our initial stage, where we are, and what should be our destination stage, means where we have to go. Means this is our initial stage. For example, think that I want to move from here to Hyderabad. The same example I will take. Okay, I want to move from here to Hyderabad. So what is my, this is my problem, AA problem. So what is my initial problem, initial stage? My initial stage is IARE. Okay, what will be my destination? Hyderabad. Right? So 3 things came into picture now. One is, my requirement is I have to reach to Hyderabad from this place. That is a specification. And the second one is, what is the initial stage, where I am? I am at IARE, and what is my destination? My destination is Hyderabad. Means trying to generate or trying to understand these kinds of things. Generally we say that it is a defining of a problem. Defining of a problem, right? What kind of problem you take, but these will be the common steps you have to apply before writing a program. Okay, once you define the problem, our next duty is we need to analyze it. What do you mean by analyze?
Route map.
Yes?
Route map.
Route map? Okay, we need to identify what are the possible solutions we have. What are the possible solutions we have? Means, for example, everybody know that from IARE, if I want to go, right, there are two different possibilities. Okay, even to go to Gandimaisama also there are two different possibilities are there. So like that we need to identify what are the different possibilities we have, right, and what will be the impact of one possibility on the other possibility. For example, if I take the first route, first left route, right, how much time I am going to take, means how much time it is going to take in order to reach to Gandimaisama. Of course from there it is a common route. Okay, what happens if I take the rightmost route, right, because it is just a national highway, right? So we need to identify these kind of things, and we also need to identify the impacts of the possibilities. Means what will be the impact if I select this particular possibility. So these kind of things you need to perform, right? That is called as here analyzing a particular problem. First, what we have done? We have defined the problem, and next we try to analyze the problem. And the third one is we need to identify the different kinds of problem solving techniques that are already available. What are the different kinds of problem solving techniques that are already available? Next, at the end, what we have to do is we need to select the best one. We need to select the best problem solving technique, and we have to apply that technique to our problem so that we can get some solution. Clear? Right? 4 different steps in order to solve any kind of AI related problem. Of course, even you can apply this problem, these steps even for your problems. First, try to define the problem. Next, try to analyze the problem, and next try to identify the different problem solving techniques that are already exist, and next try to select a particular one and apply it. Okay, so let us try to take one simple example. Right, everybody we know chess playing game, right? Okay, chess playing game, how it will be? So mostly, okay, yeah, during this my session I am going to cover two kinds of problems I am going to explain. One is chess playing and another one is the butter check problem. Okay, actually I was little bit worried in the morning session. Because madam continuously she used the word water jug problem, I thought that she is going to cover the topic. So what I have to speak in the afternoon. Okay, so see these are the standard problems. Means any speaker who is speaking on artificial intelligence, definitely they will take this kind of problem. Okay, so let us try to understand this play. Already I told that AI problems is not the general kind of problems what you deal with. Okay, there are some special kind of problems. Right? How they are special, let us try to understand. First one, chess playing game. Okay, right? Try to understand that particular chart as a 8 by 8 matrix. As a 8 by 8 matrix. Okay, so what is our now problem is, what is our problem now? We need to play the chess. Our problem is we need to play the chess. Okay, so in order to play the chess, right, do we need any previous knowledge? Means, do we need any knowledge? Yes. Yes, we need the knowledge. So what kind of knowledge we need? Rules. Right? So what those rules are? Can you name it more specific? Simply don't tell that it is moves. Can you say it as legal moves? Because you need to play the chess, right? Right? Simply I cannot move wherever I want. Okay, why? Because we know that a soldier is having different moves, queen is having different kinds of moves. So, means before starting the playing of game, we need to understand what are the different legal moves we have. Different legal moves, right? And next, what should be done? Think that you have already you have learned each and every legal rule. Okay, next what is the next step we have to do? We have to apply the rules. Right? Is it enough just to apply the rules?
No, best move.
Best move? How can you say that it is a best move?
By predicting our loss.
By predicting our loss, no. Why? Because even a single king also can win the game. Yes, there is a possibility. A lot of games are there. You can search in the internet.
Based on the operating move.
See, while playing the chess game, we are having two targets, remember. We are having two targets. The first target is, we need to understand all the legal moves. We need to understand all the legal moves, and our next step is, we need to win. Yes or no? Just not every time we have to do the legal moves. Getting my point? Or any problem here? See, while playing the game, right, we are having two targets. The first target is, we need to understand the legal moves. Right, what are the different moves we can do? Right, try to concentrate, okay? So what is the second one? We need to win the game. We need to win the game. Win the game is nothing but what?
Strategy.
When can you say that you have won the chess game? When you make the opponent king, right, in a specific position so that he don't have any legal moves. Try to understand this. Right? When can you say that you have won the chess game means whenever you keep the opponent's king in a particular position where the king does not have any legal moves. Right? Then we can say that it is a chess when you have won the king. So this is a problem. Right? We have identified some general solution now. Getting my point? We identify first the problem. What is our problem? Chess playing is our problem. Our next duty is, in general way, how can we solve that problem? We have discussed it to some points. We discussed some points. So next, what is our duty? Tell me really, are we going to play the game? See, for what purpose we are discussing all these things? Remember, we are not going to play the game. Whatever the discussions we are making, right, these discussions we need to apply and we need to develop a program. We need to develop a program. The program is going to play the game, not us. Got the concept now? So, discussing about legal moves, right, trying to defeat the king, opponent's king, everything we are discussing in order to write a program. Remember, right, writing a program is not just like writing a program for addition of two numbers, factorial and Fibonacci, all these things. We need to learn a lot of things. Can anybody guess, right, how many instructions will be there in order to write a program for chess game? You need to understand the structure of this one particularly. See, just now I told that think that it is an 8 by 8 matrix. Okay, for 8 by 8 matrix you need to generate all the positions. Means all the positions. Means for example, from this point, if there is king here, so how many different legal moves the king is having? Like that, you have to identify the different number of positions. Remember, those different number of positions, how we are going to calculate means, it will be 10 to the power of 120. Try to understand, it will be 10 to the power of 120. Means how many possible choices are there to move for each and every point there, right? We can say that for each and everything, right? If you consider, there should be 10 to the power of 120. Can anybody guess what is 10 to the power of 120 is going to give? So we need to include these number of instructions in order to write a program to play a chess game. Try to understand, right? Means if you want to write a chess playing game, right, using artificial intelligence, you have to include almost 10 to the power of 120 instructions into your program. Now tell me, is it that much easy to write those number of instructions? No. See, of course the game is going to play by the artificial intelligence machine itself. But who has to write the program? Humans has to write. So how many instructions he has to write? 10 to the power of 120. Right? Is it possible for a human to write those number of instructions without having any error? Not at all possible. Right? Still, if it is possible, right? Is it possible to implement or include all those number of instructions into a single program? It's not at all possible. Right? Of course, even if it is possible, right, definitely we are going to have some errors. Definitely we are going to have some errors. See, that much difficult when you are trying to implement something in the artificial intelligence area. That's why artificial intelligence programs are not that much simple programs. They are very, very complex programs. Okay? So, here you try to understand. Our primary goal is we need to develop a program, right? With the help of program, we need to solve a problem which is related to artificial intelligence. Okay, so in order to write the program, we know that we should need some instructions. We should need some set of instructions. But here, we are not going to call it as set of instructions, but because it is artificial intelligence, we name them that as rules. We name them as rules. Means first of all, right, after defining the problem, after analyzing the problem, after identifying the possible techniques we have, right, after selecting a particular technique and applying it to our problem, so what we have to do is, we need to design the rules, we need to set the rules, and we need to define the rules. Based upon that rules, we need to develop a program. We need to develop a program. Now you got idea, right? So our primary goal will be the same thing, that is writing of a program. Okay, so here our production systems. So how this production system is going to contribute to us means it is going to help us in order to follow a particular approach or in order to follow a certain methodology through which you can solve the IARE related problems and generate some solution. Okay, so this is all about the chess playing game related kind of things. So what about this one? We will take one more example. We will try to see is it complicated or not. Water jet problem. Do you heard about this problem anywhere? Yes or no? Yes? No. Okay. So this is a very simple problem, right? For just understanding it is very simple problem, but when you go on writing the rules, again it is going to become more complex. Okay. So you try to understand what is water jet problem is. Try to understand. Tell me. See, you are going to give two jets. Try to understand, right? You are going to give two jets, right? That two jets, right? You need to fill up with water. You need to fill up with water, and your target is you have to keep only 2 liters of water in a particular jug. Okay, so try to understand this. You are giving two jugs, right? One jug capacity is of 4 liters and another jug capacity is of 3 liters. 2 liter jugs is given. Okay, just is given, and then you are having enough water. You can fill how much water you like, you can fill it. So what you have to do is at the end, means your target point, your goal state. What is your goal state? You need to fill up, right, any of the jug with just with 2 liters of water. But remember, this jug does not have any measurements on it. There will be no measurements on it. So can you guess how you are going to solve this problem? Did you get the idea? Right? What is this water jet problem is? Yes or no? Two jugs are given to you. There will be no measurements on the jug. Right? One jug capacity is of 4 liters and another jug capacity is of 3 liters. And your target is, means your problem is, you need to fill up any one of the jugs with exact 2 liters of water. Okay, so in order to solve this one, I will take something like this. For example, the first one I will consider it as X, means for the first jug as X and the second jug is as. Okay, so what I am doing is, I am writing like this, X equal to 0 and Y equal to 0. What do you mean by this? Initially, right, initially you have given empty jugs. There is no water in X and no water in Y. So as ma'am told, right, you can follow your own strategy to solve the problems. So my strategy I am telling here, you see. First what I will do is, I will keep the first jug like this, the same thing, and I will fill the second jug with the 3 liters of water. Here, see, these equations are very, very important to frame the rules, remember. If you get the rules, it will be very easy to write the program. Artificial intelligence programs, remember 5th semester students, artificial intelligence programs are nothing but designing the rules first. designing the rules, then writing the program. If you won't understand the rules, it will be very difficult to write the program. Okay, so x equal to 0 and y equal to 3. That means that I have filled the second jug with full of water. Okay, so next what I will do is, I am writing like this. Can anybody tell me what do you mean by this? Okay, that means that I am taking all these 3 liters of water and I am pouring it into first jug, that is x. Okay, so next what I will do is, okay, x equal to 3 and y equal to 3. So again what I have done, this empty jug I have filled with water. Initial stage only I told that we are having enough water. You can use in any quantity of water you like. Okay, so now it is this case. Next what I have done is, I have represented like this, x equal to 4 and y equal to 2. Okay, okay, I will take 2. Is it a legal rule or not? First of all you tell me. See, 3 liters of gallon, sorry, 3 liters of water that I have poured in the first jug. The first jug can hold exactly 4 liters of water. So 1 will be minus. So x equal to 4 and y equal to 2. Okay. Next what I have done is, I have represented the equation like this, x equal to 0 and y equal to 2. What it means? What I have done? I have poured out, means I have taken out the water present in the first jug. That's why x became 0. I didn't touch this the second jug. Y equal to 2 will be like that only. Now tell me, did we reach our destination, our solution? What is our final destination? We need to keep exactly 2 liters of water either in any of the jug. Did we reach or not? Yes. Now 2 is exactly with 2. And I can also extend this problem. I can say x equal to 2 and y equal to 0. So what I have done here? I have just shifted the water from the second jug into first jug. Clear? Now means in last 2 steps, right, we could able to reach our goal. Now tell me, is it? Are you feeling that it is very simple to write these equations, rules? Are you feeling that it is somewhat difficult? Tell me whether it is difficult or easy. Any problem in understanding these equations? No, it's clear, no? Right? Now tell me, is it the simple way to represent the things?
Yes.
See, we have in the general terms only, I have explained how to solve our problem. Right? Now what we have to do is it the same way how we think? Why? Because we need to make the artificial intelligence to understand all these things. Yes or no? In the chess playing game also, the same thing, right? If we are understanding, it's not a big issue. Why? Because we need to generate the rules for those things and we need to write a program so that the artificial intelligence machine itself can do the things by its own. Okay, so for a water jet problem, simply we could able to generate all the possible rules we have. These we can say that these are the set of rules. But if you go into the real-time scenarios, things will not be like this. Why? Because I have given the answer in a general way. Right? If you want to write a program, artificial intelligence program, these set of rules are not enough. Okay, so what are the different kinds of steps we need? To try to see this one. Just making a move. I said the legal moves. Right? For this one, legal moves I am telling. To try to observe this. These are the equations actually we need to generate in order to write a program to solve this water jet problem. Okay, try to understand. Totally how many steps are there? 12. But here how many we have done? 2, 3, 4, 5, 6 and 7. So with these steps only it is very clear that the way how we think is not exactly same how the machines has to think. Okay, means if you want to solve this problem with the help of a artificial intelligence machine, right? So how many number of rules you have to write? 12. right? Try to understand each and everything. What is the first equation? 4 comma y. What it means? Yeah, we have filled the first jet with exactly 4 liters of water. Right? Now tell me, did we touch y? No, we didn't touch y. Second one, x comma 3. Means the same thing opposite, right? Means we have filled the second jet with 3 liters of water and we kept the first jet in the same way. Here try to understand, here we are writing the rules not to solve the problem. There we have written the rules to solve the problem. Okay, here with these statements we are not going to solve the problems, but these steps are going to help us to write a program, artificial intelligence program. With that we can easily solve that one. Okay, so what do you mean by this one? X comma d, x minus d comma y. You can take the help of this one. Pour some water out of the 4 gallons. So you need to understand how the rules are framed. You need to understand how the rules are framed, right? So what I am writing is x minus d. Whenever I mention it as minus, that means that I am taking out some of the water from it. Okay, so x minus d comma y means if your intention is that one, means to remove the water from the first jet, then you have to write like this. If your intention is in a reverse way, means not taking the water from the x jet but with the y from the y jet, so you have to write x comma y minus d. Similarly, see 0 comma y means what it means? You are emptying the first jet. Empty the second jet. Now you can 4 comma y minus 4 minus x. So what I am doing? What I am doing? What is this 4? The capacity of the first jet means that first jet is having 4 liters of water in it. Now, from that 4 liters of water, I am trying to remove some water from it. 4 minus x means from the jet 1, which is having already 4 liters of water. Already minus is there, means you are trying to remove some water from the first jet. See, pour water from the 3 gallon jet into the 4 jet. Sorry, where this statement we have written at the y side, not at the x side. So pour water from the 3 gallon jet into the 4 gallon jet. Here liters or gallons, they are the units only, until the 4 gallon jet is full. Means you are removing some of the water from y and pouring it into x, right, so that the x can get full. Any problem here? See, that is the difference with the general way of understanding the problems and way of understanding the problems in terms of artificial intelligence. See, I am trying to make it clear. What we are doing here, we are removing some of the water from y. Where minuses are there? At the y side or at the x side? Y side means we are removing some water. Okay, where we are pouring? Into x. Removing some water from y and pouring that water into x, whose capacity is of 4 liters. See, these things need to be explained more clearly to the artificial intelligence machine, otherwise it is going to give different answers. Okay, right? Now you try to understand this one. What do you mean by this? X minus 3 minus y comma 3. See, it is a continuation, okay. It is a continuation only. Here what we have done? We have removed the water from the second jet. Here what we are doing? We have mentioned the minus at the first side, first parameter. Means removing the water from the first jet and trying to pour it into the second jet. Pour water from the 4 liter jet into the 3 liter jet until the 3 liter jet gets full. Next one, x plus y comma 0. What do you mean by this x plus y comma 0? Tell me what happened. From which jet you are taking the water? From the second jet, right? From the second jet you are taking the water and pouring it into the first jet, right? Up to what extent? Up to the second jet gets empty. The second jet gets empty. What about this? Taking the water from the first jet and pouring it into the second jet until the first jet gets empty. What about this? 2,0 means pour the 2 gallons means 2 liters from the 3 liter jet into the 4 liter jet. Means you are taking, see this statement, this one. Okay, taking the water from the second jet and pouring it into the first jet and make the second jet empty. Okay, so this is the second one is 0, 1. So what is empty the second gallon, 2 gallon in the first 4 gallon jet on the ground. You are pouring it on the ground. Here, in these two cases, here what we have done. See, previously in the previous step, what is there? X equal to 4. But here, x equal to 0. Means what happened to this 4 liters of water? We poured out. Right? Poured out. That means that if you want, if it is your intention, you need to represent the rule like this. 0, 1. Means by understanding and by implementing these set of rules, 12 set of rules, right, you could able to write a artificial intelligence machine which can solve the water jet problem for us. Okay, try to understand the complexity of the problem. Right, if you could able to easily analyze what the problem we are dealing with, then getting of solution is very easy. 50% of work is done if you are able to write the set of instructions. So production systems are going to help us in order to write this set of instructions. Okay, but remember, production systems not only going to deal with this kind of things. There are some other options which are also available. We will try to see those things. Now you got the idea with this how the artificial intelligence programs are entirely different with the traditional programs, traditional kind of problems. Any issue here? Any queries? Clear? Right? Now we try to understand. So what is our production systems? Right? Production system is just like a architecture. Right? Architecture which is going to help us in order to solve AI related problems and in order to generate some results for us. Okay, this is a definition taken from the textbook, right? So production systems are useful to structure AI programs. From the starting point onwards, I am telling that our primary intention is to write the AI programs. To write the AI programs, we need to prepare with an instructions, set of instructions. Those set of instructions, we are naming it as set of rules in the artificial intelligence terminology. Okay, means for us, these are the instructions. That means the previous 12 one are the instructions. Okay, right, in a way that facilitates describing and performing the search process. Ma'am also stressed this particular point. Production systems are going to solve a specific kind of problems called as search process. Remember, most of the complex problems in artificial intelligence, they can be solved only with the help of this search process. We are going to have a very beautiful example, right, which can makes you very clear what this search process actually is. Okay, right? We will try to make the things more simple. The first element of production systems. What the production systems will have? Right? Can anybody describe what that diagram tells us? A lot of information is there in the single slide. The first element, or we can say the first component of production systems is generating some set of rules. Generating some set of rules. Now, how the rules will be? How the rules will be, right? The rules will be in this particular form, you try to observe. It will be in the form of like this. This is the way how we represent mathematically. Now we need to understand what this C is and what this A is. Right? So we can say that C is a condition. What condition we need to apply? That will be at the left hand side. Right? So at the right hand side, what will be there? Action. Means when that particular condition is met. Remember, for your particular situation, for your situation, what will be the condition it is meeting, right? If that condition is met, what action you need to perform. For example, think that I have started my search process from IARE. My target is to reach to Secunderabad. So initially, after making one legal move, right, I am at Gandimaisamma now. Okay. So when I reaches to Gandimaisamma signal, there are 3 different roads. Yes or no? Means how many conditions we have? 3 conditions. Okay. When particular condition is applied, so what action I need to take? Right? This strategy generally it will be played by the Google Maps. Right? Unfortunately, if you are missing the road it is showing, what it will do? It will redirect you, right? It will give a different path so that you can reach to your destination. Just like that. Means whenever in a particular situation, whenever a particular condition is made, right? So what action you need to take out. So you try to understand. At the left hand side, we are going to have the pattern that determines the ability of the rule. Okay, means to that particular situation, is that rule is applicable or not? Okay, if that rule is applicable, then it describes the operation to be performed. So what I have to do? So what I have to do, that will be at the right hand side. So for simple understanding, you see, LHD, okay, describes the applicability of rules, and LHS it is, and RHS describes the operation to be performed. Whether we can apply a particular rule in this particular situation or not, that is going to decide by the condition, right? If that particular condition is met by your situation, then what action you need to perform? That will be given at the right hand side. Means every time whenever you are trying to generate new rules, right, you need to follow this particular way of structuring the rule. C, A. Got it? Fine. So what are the different components we are going to have? The first component already I told that it is set of rules. Means our first step will be writing of set of rules. Okay. So here the set of rules is nothing but a system that creates or applies human-made rules. Remember, these rules are made by us only. Already mentioned, right? Even though we are developing a program for artificial intelligence system, right? But ourselves we are writing the program. Okay, so that means that these rules are framed by ourselves itself. Okay, we are doing it of our own. And next one will be knowledge base. What do you mean by knowledge base? Okay, generally we use the term called as database. Okay, knowledge base, it is going to have some information. We can say that some specifications or some already existing rules, we can say. Existing rules which are already available in order to solve a particular problem. Some rules will be too general. Too general means you can apply those rules to any kind of problems. You can apply those rules to any kind of problems, but some problems are too specific. Means you cannot take that rule and you can apply for some other kind of problem. For example, you see the rules whatever we have discussed here, right? You cannot apply for chess playing game. Why? Because chess playing game is entirely different and water jet problem is completely different. Okay, so what are the existing rules are available? Right? Which rules are too general and which rules are too specific? That kind of information you are going to get in a particular place called as knowledge base. It's just like a database, right? Database means having a lot of information in it. And next one is control strategy. What do you mean by this control strategy? What happens for a particular situation when more than one condition is meeting? For example, think that I reached the point Gandimaisamma signal. Right? One of my friend told that in order to reach Secunderabad, right, you are going to find a 4-floor building. Means at the signal there will be a 4-floor building. From that point you need to continue your journey. Getting my point? I will try to give the things very simply. My target is to reach Secunderabad, right? So what is after making one legal move, I have reached to Gandimaisamma signal. Right? At Gandimaisamma signal, my friend told that wherever there is a 4 floors building, you need to move in that direction. You need to continue your moving in that particular direction. But unfortunately, right, two lines is having two same 4 floors building. So what should I do?
Color.
Huh?
Color of the building.
My friend didn't know that one. My friend only given the information that wherever there is a 4-floor building, you try to move in that particular area. Trial and error. Of course, already regularly we are moving in that particular line. We can do some trial and error. But if you are doing the same thing in USA, you will not come back. That will not be. That is the thing. So, control strategy, right? It is nothing but a technique, or you can say that it is a strategy. It is a strategy that is going to tell that which rule has to be applied. Okay, which rule need to be applied? Why? Because we have framed 12 rules to solve the water check problem. So which rule we need to apply at what point? Okay, when there are a situation where 2 rules are matching, that will happen, remember. That will happen. So in that case, what decision we need to take, that completely depends upon the control strategy. Control strategy is going to give us such kind of informations. Right? It is going to remove some ambiguity, so that we can continue our journey. Okay, these are the 3 different elements we have in the production systems. Along with these 3, one more is also there. Rule applier. Rule applier, who is going to apply the rules. Try to understand, right? First is the set of rules. We are framing some instructions to write the program. And the second one is knowledge base, which is going to have some extra information, right? Means some extra rules which are too general to a particular problem, or to any kind of problem, or it can be too specific to a particular problem. And control strategy is going to help us whenever we are stuck in somewhere. Okay, for the simple understanding, I am giving these examples. Okay. See, one or more knowledge or database that contains whether information is appropriate for a particular task or not. Even that is also going to decide by the control strategy, whether can I apply this rule to this particular situation or not. Okay, so a control strategy that is going to specify the order. Even order is also very, very important. Yes or no? We have framed 12 set of rules in order to solve this problem. Can anybody say which rule need to be applied at what point? See, for simple understanding, we have framed like this. With these statements only we can say that, sir, x equal to 0, y equal to 3 should be the first rule to apply. Right? And x equal to 2 and y equal to 0 should be the last rule to apply. But what about the 12 rules we have framed? Can I apply the first rule first? Can I do it or not? We cannot guarantee. So what happens if I go on applying the rules as it comes in a sequence? Means first rule first apply, second rule second apply, third rule third apply, like that. Of course, even if you apply the rules in the sequence, you are going to reach to a particular destination. You are going to move to your goal state. But actually, according to morning session, time is also very, very important. Means if you are following the sequence, how you frame the rules, if you apply to a particular problem, of course you are going to get the solution. But it will not be the optimal solution. It will not be the optimal solution. Why? Because time is also very, very important for us when we are dealing with artificial intelligence kind of problems. Okay, so what we have to do? If we could not able to reach to the goal, right, with a shorter period of time, so how we need to apply the rules? How we apply? If sequence is not helping us, so what will be our next step? Tell me. Did you got my problem or not? See, generally sometimes what happens now, when we are traveling in a particular traffic, first we will select the route what we know. Okay, we will move in that particular way. Right? What happens if you stuck somewhere? You will definitely take another way. But most of the times what happens, that another way is unknown to you. Yes or no? Randomly you are going to move in particular lanes. Okay, just by making some wild guess. Means when applying the sequence of rules is not allowing us to get a solution, so what we do? We will try to pick up the set of rules randomly. Means for a particular situation, which rule, for example, rule number 11 is applicable to that particular situation. You try to collect that rule, pick up that rule and apply it. You will get the solution. See, within the shorter period of time. Means how many rules you are applying? Only one rule. But previously, if it is sequence, unnecessarily you have to apply from rule number 1 to rule number 10. It is simply waste of time. Got it? Any problem? Right? Means when we are dealing with control strategies, if you go on applying the rules in a sequence, right, that is not going to help us. Time complexity will come into picture. So what we have to do is we need to pick up the rules randomly and we need to apply them. Okay? Try to understand this one. Features of production systems. What is the first one? Simplicity. Okay, right? When compared to programming languages, right? According to my knowledge up to this point, right? I say that artificial intelligence kind of problems are somewhat simple to write. Why? Because, right? Anywhere you go, there will be just like if-then type of conditions. There is no such kind of more complex things what we see in Python or C language. That's why we say that the production systems, if you use it to write the rules, it is having some simplicity. It is giving simplicity to you. That is unique and uniform structures you are going to have. Right? Every condition, every rule you take, that rule will be in the form of if-then. Okay? Right? And next one is modularity. What do you mean by modularity? Knowledge is available in discrete pieces, means as a collection of independent facts. Means one rule is completely independent with the other rule. Did you observe that 12 rules? Is it having any dependency with another? Means whenever that rule 10 is applicable, right, then only rule 11 is going to apply. It is not such kind of things, right? Whatever the 12 rules we have framed, all those 12 rules are completely independent to each other. That is called as here the modularity. And second one is modifiability. You can modify any kind of rule. Why? Because they are completely unique. Right? When they are unique, right, the modification of one rule is not going to impact on the other rules. Okay, so what you can do, even you can modify whatever the rules you like. See here I have framed my rule somewhere. Right? If you start solving the problem, the same kind of problem, you are going to generate different rules. So we least bother about what kind of rules we are framing. We only bother about whether we could able to get the solution or not, and also whether we could able to get it within the shorter period of time or not. That is important. Okay. And next one is knowledge intensive. Too specific to a problem, remember. Whenever you are trying to prepare some set of rules, those rules need to be too specific to your problem. Okay, so these are going to provide you by the production systems. Any problem up to this? What happened? So silent. Sometimes we get fear, man. Right? The students, if they are sitting silent, right, we will get some kind of doubts whether they are sleeping or. If it is a case, then we will stand and we will listen the class. Entire sleep will go. Now tell me whether you could able to get it up to this point. Clear, no? Right? Production systems, right? So from 4 different classes of production systems are there: monotonic, non-monotonic, commutative, and partially commutative. Okay, for time being, I am skipping this particular slide. So what the production system is going to provide to us? Already I mentioned that it is a methodology or it is an approach which will help us to solve a problem and get a solution for us. Okay, so the problem solving, how it will be in the simple terms, you see, define the problem's state space. We are going to see what this state space is now. Okay, state space including the start and the goal state. What is my start place? If I am working with a traveling problem, my starting space is, my start state is IARE and my goal state is Secunderabad. Okay, and the set of operations for moving in that space. See, definitely I need to apply some operations, otherwise I am not going to change my position. Okay, I have to start traveling from this particular point. Na? So what are the different operations we need to apply? that these particular things it is going to help us to solve a particular problem. Start point, goal point, and what are the operations you need to apply. Okay, right? And very important thing, this is very important, conduct the search process. As I mentioned, once again I am stressing it, right? Production systems are helpful in order to deal with more complex problems of applications by the help of this searching technique. Okay, that's why conduct searching for a path through the space from an initial stage to the goal stage. Clear? Any problem here? Good. Some points we are already ignored. What is that point? See, how to decide which rule to apply next during the process of searching for a problem to a solution. Among the total number of 12 number of rules which need to apply first, and then after next, like that. Okay, so this question, it is going to arise some more rules we have to work on it. We will see how we can work it with the help of one of the concept, right? That concept we have. See, when can we say that we are moving in the right path? For example, we have set some set of rules, and next our duty is we need to write the program. Before writing the program, we need to decide are we in the right path or we are moving in a different direction. So these things, three requirements of a good control strategy. Means how can you decide that your moves are correct? You are moving in a right path. The first thing you see, it should cause motion. Means for example, think that you have applied some condition to your initial stage. You have applied some rule or some condition to your initial stage. So your initial stage should change. For example, think that my goal is to reach to Hyderabad. I have taken one decision when I am standing in IARE. So when I took the decision, right, my stage should change. Means after taking a particular action, I should not be in IARE. I should be somewhere else. And that point should be, right, a good point, good position. I should get a new good position which should really direct towards the solution. Remember, if I make a move from here to Dundigal, right, is it a legal one? Is it a correct path I have selected? Well, because my destination is towards Hyderabad. Right? For doing that, I have taken some action. Remember, I have selected a wrong rule. Right? When in that case, what happened? Unfortunately, I found in Dundigal. Okay, right? That should not happen actually, right? It should cause motion, means your position should change continuously, right? So that you can reach, you can move towards the goal stage. And next one is, it should be systematic. It should be systematic, means from here to Gandimaisama I have taken left line. Right? I got some confusion. Again I came back from Gandimaisama to again IARE. I am moving here only. Why? Because I am selecting different rules. I am selecting the rules which are not applicable to that position, situation. Getting the things. That's why it should be systematic, right? And it should be effective. Every step you make, that should make you to reach to your goal stage. That is important. Okay, don't worry, I am going to tell you each and everything with a simple example. Right, that is called as heuristic search. Heuristic again, assumption. Okay, that we will take, you will see. Okay, these things I already have explained. Okay, so I will move to the last example. So directly I am moving into the heuristic search. Means it is not an independent topic, remember, right? This topic is exactly matches with the explanation whatever we have done so far. Okay, so what do you mean by this heuristic search? You try to see. This technique we are going to select whenever we are dealing with more complex problems. To solve many hard problems effectively, it is often used. First you see, to compromise the requirements of mobility and systematically, right? To construct a control structure that is no longer guaranteed. So it is nothing but here the heuristic is nothing but it is a method, or we can say that it is a technique which is going to improve the efficiency of our search process. Okay, so this is a word, right? Heuristic is a word taken from the heuristic meaning, right? That is nothing but it is called as to discover. Heuristic means to discover. That's why we are using that term in the search process. Okay, right? Heuristic method. We will see some things we are going to neglect in the heuristic method, right? And something we are going to consider. But remember, heuristic search method, it does not guarantee every time it is going to give the best result for us. But anyhow, we are going to get a good result. Best result and good result, right? What is the difference between these? What do you mean by best result? Means how much you are expecting in the examination, the same percentage you got. Best, right? Good. Not reached to that particular point, but anyhow it is okay. Okay, so heuristic search technique is also some kind of same thing. Anyhow, you are going to move from initial stage to goal stage, right? But we cannot guarantee that that is the best route we can select. Okay, right? I will take one simple example. Every doubt, whatever you have in your mind, that will be clear.
In AI problems, time complexity is considered.
Yes, time complexity is also very, very important.
So you always try towards optimal solution.
Yes, optimality is very, very important when we are dealing with these AI problems. See, anyhow we can solve the problems. Remember, even these problems we can solve, the humans also can solve, but they are going to take years of time to complete that task. Right? You try to understand the chess playing game itself. Right? Humans are playing the chess from long years back. Right? What about the machines? You try to observe the behavior of the chess. Right? Previously, initially when the chess was introduced for the first time, right? Their moves are static. Means whatever kind of moves you do, that it least bothers. It is going to give some static moves, right? And it is going to fight with you. That's why most of the times the machine is going to fail. Means every time the human is going to win the game. But what about the today's chess playing game? Depend upon your moves, right? The artificial intelligence machine is going to take a different move. Okay, means here every time the machine itself is looking for the optimized result so that he can beat the human. Of course, even it has happened. A lot of AI related chess playing game machines, they have already beaten the world champions also. Okay, optimization is also very, very important, and we will stress on this one. Right, there is an example on that. I will try to expand the example, and I will stress on the optimization concept. Okay. You try to observe that. See, this example is very much interesting, right? Those who are sleeping, you can wake up, no problem. Okay, see, you try to understand heuristic search technique, how it will be, right? What is my initial stage? Here, right? Here is my initial stage, and my goal stage is here, right? And I have given some circles and with some numbers. Can anybody guess what that numbers tells us? Yes? No? It is not a neural network? Yes. It is a time. It is a time taking to move from one particular position to another position. For example, think that here at this particular point there is an AI agent. AI agent means who is performing the search process. What is his goal? AI agent goal is he has to travel from the initial stage to the goal stage, right? By taking the optimal position. That is also very important. Optimal position is nothing but here the shortest position. The shortest position, right? Can anybody guess what will be the shortest position now? For example, think that AI agent has started from here. What he will do? He will try to generate two values, right? One is 10 and another one is 50. That means that in order to move from this point to this particular point, the AI agent is going to take 10 seconds of time. Here it will be 50 seconds of time. So which one he is going to select? 10. Means this we are going to ignore. This we are going to ignore. Next come to this particular point. From here again, how many choices are there? Two choices are there. The first choice is having 30 and second one is 20. Means 30 seconds time to reach there and 20 seconds time to reach here. So which one is the best one? 20. Time complexity is there, na? So 20 is going to select. So come here. Next, from here again two choices are there. 10 and 60. 10 seconds of time to reach here and 60 seconds time to reach. So which one he is going to select? 10. So here, now the position of A agent is here. Next, immediately from this point he is going to move to the gold stage. Now what is the path he have selected, you see? From 0 to 10, 10 to 20, 20 to 10 and 10 to last. So what will be the answer? Value, total value? 40. Right? First is 10, 20, 10. So what is this? 40. Okay, what happens if the AA agent select this one? Already I am telling, heuristic search method is not going to give you the best solution, but it will give you a good solution to you. Okay, you try to observe. If you select this one, 50 seconds, already here only we are moving from that 40. For the total time, how much time we took from initial stage to gold stage? 40 seconds. But for a single move here, you are taking 50 seconds of time. So now tell me, did we selected the best path to reach from initial stage to gold stage?
Yes.
Yes?
Yes.
Do we have any other path which can bring the value below 40? You try to check it out? No? See for 1 minute. Maybe you may find the answer. 45. Okay, anyhow we are going to ignore this one. Why? Because here itself is 50 seconds. So 10, 30, 45 and here. In total it will be 30 plus 10 plus 5. It will be 45. Okay. Mean now tell me, did we get the good result or not? Did we get the shortest path from initial? So that we can move from initial stage to final stage, gold stage. But still there is some flaw in this program. Tell me what is that?
So there can be any states which may have the least value, but the number of states could be more such that the value was more.
So
The number of
at each turn, like we are just checking which is the lowest, but in between there may be a higher number which the program may not check, and then it may have to increase the price.
see, after Gandhi my summa, what will be the situation? I am not going to think. First I am going to think which is the shortest path to reach to Gandhi my summa signal. Okay, after going there only I could able to know which one is shortest and which one is longest. But see, every feature is known to us, but in the real time is it the case? No. Here our intention is we need to understand how this heuristic technique will work. Okay, so with this example you are saying that this is the best path. Good path or best path, tell me.
Best path.
But heuristic technique will not give best path. It is not the best path. So what we have to do is we need to identify the optimized path. Optimized result we need to get. What is that? Can anybody, you can make some guess. You can give me the answer. How can I optimize this? You are in the right track. Somebody thinking about that.
Delete extra nodes.
See, if it is deleting the nodes, I cannot remove Gandhi by Sama from the map.
But we can remove from our consideration, sir.
How?
Sir, we can make that 30 and 5. We can combine them and make 35.
We can combine and make 35. Which one?
First one, 30 and 5.
No. These nodes anyhow you cannot change.
Sir, it's linear, there is no
Sir,
other
linear,
possibility, so you
Ah.
can reduce it.
Yes.
That's too linear, sir. Like there is no divisions from there, so we could actually combine them to reduce our complexity in the data set, sir, or our set of problems.
Now tell me, right? You are telling that there is some complexity in this one. That's why you could not able to get the best path. Now how you will remove this the complexity? Nothing but optimizing the problem. See, AI agent, right, is given two possible solutions. One, either move to this particular side and to this particular, right? But AI does not want to take either two. The AI agent does not want to move either to this point or to this point. So what he can do? Very good. What he can do is, he can generate one more path. He can generate one more path from here to here. If the path is moving here, see. Can I write down this? What happened there? You try to understand what happened there. See, in order to get or in order to optimize, try to understand. In order to optimize the result, right? We have generated one more path, right? Directly from the initial point to this node. Is there any such rule that you should not supposed to go in that way? Road you prepare your own road. What happened? Is there any problem with that? See, remember. See, try to understand. So I am giving the answer for that guy. Okay. For example, think that in that particular area, your house is the first house. Definitely there will be no road. So what to do? Here also the same case, right? We don't have any road at present. We believe that if we construct a road from this point to here, definitely it will be the shortest path. Why we are preparing these flyovers and everything, some bridges in between the rivers, in order to reduce the distance between two locations? You try to understand. Yes? Where? Directly? Okay, I got your idea. If you do that one, what happens? The distance between two nodes is going to increase anyhow. When the distance between the two nodes is more, definitely it is going to take a long time to reach there. It does not mean simply to draw a line, right? You need to see whether it is the shortest path or not. Okay, so whenever you draw these kind of things, right? See, you can think in a crazy way however you like, but that is not going to be applicable here. Why? Because selecting the perfect route.
Here to airport, there are multiple paths, right? ORR is the single route. Otherwise, many destinations you can cover and reach. So, which is the longest path? ORR. But that's what you are saying, that from initial to goal state there is a single path. Yes, if you can build that path. So, is it not longest? Is it an optimal path? No, it's not. It is the longest route. It will take ORR. Yes and no, to agree or not? If you go to the city, multiple test routes, then it will be optimal path. That is the case.
See, in our example, as ma'am told that time, if you consider only the time, so what you are going to do, even though it is the longest path, you are going to select it. If it is a time. But here, time is important as well as shortest path is also very, very important. Why? Because what we believe that if we have a shortest path, it is going to take less time. Don't compare this process with the traffic of Hyderabad. That's why you are getting different questions. So when I do like this, what happens from here to here, in order to move, I am taking only 20 seconds of time. So 20 seconds plus 10, that's it. What happened? 30 seconds. Means if I could able to generate a new path from this place to this place, within just 30 seconds of time, I could able to reach from initial stage to the goal stage.
20 to 5 also we can generate a path now, sir. Then we
From 10 to 10.
10 to 5. 10 to 10.
Yes, that is also an alternate path. That
Yes.
may be optimal.
Optimal.
That's why.
Remember, optimization means It is a okay, it's okay.
It is one of the best solutions.
When compared with the existing answer, this answer is somewhat better to us.
Okay, this is also fine. 20 plus 5, 25 is still more optimal. Yes, it is just an example. There may be many optimal solutions.
There may be many optimal, right? If you go on discussing that, right, some people will say that, sir, why it will take 50 seconds? Why? Because the distance is very less, so you make it as 50.
Sir, can I ask something?
The problem should be too specific and solution should be too general. Yes.
Actually, it's taking 5 seconds from the node 13, sir. And it takes 20 seconds when we consider from node 10, not from byte 0. Sir, actually it's not possible, sir.
Means this line is not possible.
Yes, sir.
This line.
Lost in the diagram.
Okay. If you feel that this line, this one, huh?
Yes, sir.
If you feel that this one is not giving the better result to you, don't generate it.
When we travel from node
See, the AI agent, remember, here who is traveling, not you and me. The artificial intelligence agent is moving, means the intelligent machine, means the machine should be so intelligent so that it can think of its own and it can apply the knowledge what it has, and finally it should generate the shortest
See,
path.
it depends on the problem. The smallest route is not always the optimal solution.
Yes.
It depends on multiple factors. So we cannot prove here that 25 or 30 is the optimal one. Don't go by that number, which is the minimum distance, the shortest distance. The distance may be little more, but consider the other constants and factors. Based on that, AI agent will choose that is the optimal path. I hope it is clear, sir.
Yes.
It makes some sense.
Including different factors, we
See,
find
only
Even, see.
if it is a DAO problem, shortest path algorithm, then you have to consider only shortest path is the best answer. But in AI, only one aspect is not the optimal solution. You have to go with the heuristics.
Even the things are going to change. The things are going to change if you are applying, adding some more complexity to your problem. Presently, my problem is to reach from IARE to Secunderabad, right? Now what I will do is I will try to add some more complexity to the problem. That is, right? I don't want to directly move to Secunderabad from this Balagar point. So I want to touch Kukatpalli and then I want to reach to Secunderabad. So what I am doing, I am adding some complexity to the problem.
Okay, when two opponents are, means two players are playing chess game, what is their goal? Their goal is to only beat the other one? No. It is one of the reasons to beat the opponent. What there are other factors also in chess game through which they have to show their improvement in the performance in the different events. There are other factors also. Those who know chess game, they might be knowing. Number of moves, time they have taken to make a move. Other factors are also there. All together that makes point. Is it understood? Final goal is to beat the opponent. Is it understood what is a heuristic move and what is a heuristic solution approach? It is different from a general approach where you think your goal is to beat your opponent. No, it's not like that.
We are just assuming that this could give an optimal solution for us. Okay, right? Just it is our assumptions. Heuristic itself is nothing but the assumption. But anyhow, see, as you are giving different, raising different questions, of course, if you go on implementing those questions, definitely they may give a shortest path once again. Some other shortest path, not even 40 or 30, maybe sometimes 25 also. Okay, right? That's why every time we say that heuristic, with the help of heuristic search, right, you can get a good result. Right? There is a concept called as traveling salesman problem is also there. As you raise the question, I am taking this one, traveling salesman problem. For example, take that these are the different locations, right? Traveling salesman, you know, right? The salesman, he is starting from the initial point and he has to reach to the goal stage, means the end point, right? By touching each and every city present in between these two locations. Right? So, what is the best solution he is going to pick up? At that point also, he can select the heuristic technique. But remember, in heuristic technique, you are going to lose some of the things. You are going to lose some of the things. Means, for example, your intention is definitely how to touch this node. Just now I mentioned, right? Via Kukatpalli, I have to go to Secunderabad. If I say like that, even though if it is not the optimized, you have to take it. So at that point, what happens? It will be 0 to 50. From 50 to again it will be 15, then 20, and okay, like this it is going to happen. That's why, right? Whenever we are dealing with the AI-related kind of problems, you cannot add the complexity to the problem. If complexity is added, the set of rules are going to change. Framing of set of rules, of course, anyhow you can do it, but what about the application? You cannot apply those rules. If you go on applying, again the complexity will increase. Means you will be at the writing of rules itself. Then when you are going to write a program. That's why don't try to make the problems more complex. Why? Because the AI problems itself are complex. Okay? Hope you understood how this heuristic techniques is going to work for us. Okay? So this is all about the today's session. I hope you understood this production systems concept. If you have any